Alrighty, so we are continuing on with logs today. We yesterday looked at how to rewrite logs into exponentials and exponentials into logs. So now we're going to review some log properties. Yesterday, like we talked about, if you have a log with base 10, that's a common logarithm, which is just written as log of x. You don't have to put the little base on it. And a natural log has a base e, looks like this, ln of x, like log naturel. One of the things that I think we kind of did discover and talk about yesterday a little bit is that if I have log base b of 1, so if I was to rewrite this as an exponential, I'd put b to this power equals 1. What would the power have to be to get 1? 0. Anything to the 0 power is 1. So no matter what the base is, if you take the log of 1, it's 0. Then if they match log base b of b, your answer is 1. Because that would be like b to the first equals b. Okay? So I'm sorry, I didn't mean to rip it out of your hands. I was trying to help you. All right, so log base 6 of 1, what would that be? 0. And if you don't just remember the property, rewrite it as an exponential. 6 to the x power equals 1. Okay? Log base 4 of 4 would be what? 1. Okay. All right, so then we have a product property. You are taking a log of an argument where there's multiplication there, right? So that's going to become log base b of m plus log base b of n. So just like with exponentials, if you multiply two somethings with the same base, you add the exponents. So here again, multiplication and addition are connected to each other, okay? And it works the opposite way as well. So we're going to be condensing and expanding logs. So if we're going to condense them, the logs have to have the same base. So those are both log base 3. So I can condense them into one log base 3, but I don't add the 8 and the 3x. I multiply them, so that would give me 24x. Okay. If I'm going to expand it, then it would be more like what we just wrote for that property there. So the first thing I would need to do here, because I have a bunch of subtraction, what I need there is multiplication. So I need to factor. This would be the natural log of, and then I can get two little binomials there. What would the first one, well, they both start with x. Okay. And then what would my two numbers be? -2 and 1. Oops, plus 1. So now I have the natural log of these two things being multiplied together. So I can change that into the natural log of x minus 2 plus the natural log of x plus 1. Okay, this look familiar? This shouldn't be brand new, no matter which class you had last year. All right, so multiplication leads to addition. Division is going to lead to subtraction. So this would become log base b of m minus log base b of n. So if I condense them, again, they have to have the same base. So what is the base of these two logs here? 10, okay? And I don't have to write it. So it's just log, I would just have log of 80 divided by 16. And then what is 80 divided by 16? 5, very good. Okay. All right, so here I'm going to expand it into 2. So this will give me log base 2 of the numerator minus log base 2 of the denominator. And there you go. Okay. Then we have our power property. And remember, these things only work with logs. Okay, you can't go applying them to everything. Thank you. Here, let me have you pass this. Thank you. Thank you. Oh, here you go. Logan. Sorry, move whatever you need out of the way back there. Okay, so you can take the exponent. So log base b of m to some exponent. That exponent gets to come out front, so it becomes n times the log base b of m. Whew, sorry. So then if I'm going to condense it, whatever I have out in front of the log can become an exponent. So this can become natural log of 9 to the third power. Does anybody know what 9 to the third power is? It's okay. I don't expect you to know. It is 729. What did you say? 81. Yeah, it's not 81, but thanks. Thanks for playing. All right, then we're going to expand. Here's my exponent. It's going to come out in front. So I got 2x times log base 7 of 3. Okay, listen, because if that 2x was 2 terms, when I bring it out in front, I need to make sure that it was in parentheses so that whole thing is getting multiplied by the log. So anytime you have anything with more than one term, it's always safest to put it in parentheses when you're dealing with it. Any questions at all? All right, and then change of base, we actually talked about yesterday, but it was on this form, so I figured just everything can be together. Remember, you're going to change this into just log of A over log of B. The base goes in the bottom. So this one would be log of 138 over log of 5. And this would be log of 2 over log of 14. Okay. Any questions at all? All right, then flip it over. Okay. So we're going to start with the product property. I know you have it on the other side. We'll just rewrite it right here. This becomes log base b of m plus log base b of n. And remember, it can go backwards and forwards. So I have number 1 is log base 3 of 9 plus log base 3 of 5. They have to have the same base, which they do. So this becomes log base 3 of what? 9 times 5, which is 45. Right? Everybody okay with where everything came from? All right. What's the base of the log in number 2? 10. Okay. So this just becomes log of 6 times x minus 3. And then we can distribute and get log of 6x minus 18. But notice how that has to stay in parentheses. Otherwise, it's going to look like log of 6x, and then you subtract 18. And that's something completely different. Okay. So parentheses definitely matter there. Everybody okay with all that? All right, what is the base of the log in number 3? E, good. So this becomes natural log of 12 times x to the what? 5th, good, because you add the exponents. We all good? All right, so now I need to expand, and there's different ways to expand, but on this it will tell you exactly what to do, and it says I have to use the product property, which means I need that 72 to actually be 2 things that are multiplied together. So what are 2 numbers that multiply to give me 72? 9 and 8. So I can make this log of 9 plus log of 8. What's another 2 numbers? 6 and 12, right? Yeah. So, or it could be log of 6 plus log of 12. There's actually an infinite amount of answers, and you would only have to put one. I just want you to see sometimes, and they just give you numbers, you could have a different answer than somebody else, and it's totally fine. Okay, we good so far? All righty. So then I know what we have here is a quotient, but it says to use the product property, which means I need two numbers that multiply, not divide, to give me 9/10. So if I did the natural log of 9, then the next one would have to be the natural log of what? 1/10. Good. Because 9 times 1/10 is 9/10. Very good. We all good? All right. Now, once again here, I need to factor. So this is log base 5 of, what kind of factoring is that? Difference of squares. So it would be x plus 2, x minus 2. So that gives me log base 5 of x plus 2 plus log base 5 of x minus 2. Okay. Any questions? All righty. Now we're going to condense. Now we have the quotient property. So this is log base b of, let me move over some, I'm writing too big. Log base b of m minus log base b of n. Okay. So when I have two logs that have the same base, I can change that into one log with division. So this becomes the natural log of 96 over 6. What is 96 divided by 6? 16. 8, two logs, same base. So this becomes log of 8x to the 10th over 4x squared. That reduces to log of what? 2x to the 8th. Very good, because you subtract the exponents. Any questions at all? All right. This one here, I would be log base 7 of the square root of 40 over the square root of 5. If I'm dividing two square roots and there's no addition or subtraction, can I reduce what's inside there? Yes, that's legal. That's legal. That's okay, as long as they're both under the square root. So this is going to give me log base 7 of the square root of 8, but I can reduce the square root of 8. What is that? 2 square root of 2. Very good. And if you got to go off to the side and do the tree or whatever, that's totally fine. Any questions at all? All right. So now I've got to expand using the quotient property. So I need two numbers that divide to give me 8. So 16 and 2. So log base 3 of 16 minus log base 3 of 2. Or what's another two numbers? Wait, yeah, 24 and 3. And what's log base 3 of 3? 1. So really this could be log base 3 of 24 minus 1. We'll leave it like this, but we could keep going. We don't need to. We good? All right. So then again, we're using the quotient property. This one's fairly simple here. It's a fraction, so it just becomes a natural log of 3 minus a natural log of 4. $12. It's pretty straightforward as well. This would just become log of x minus 7 minus log of x plus 1. Any questions about where any of the numbers are coming from or anything? All right. So now we got the power property. Sorry if I'm going too fast. This exponent gets to come out front. So this becomes n times log base b of m. So we're going to condense, which means we take what's out in front and it becomes the exponent. So this becomes log of 6 to the third power. What is 6 to the third power? Anybody know? 216? It's 216. Xavier. How did I miss him? Sit up. All right. This 1/2 comes up here, so I get log base 4 of 81 to the 1/2 power. Yes, because something to the 1/2 power is the same as the square root, so this is log base 4 of 9. All right, we good? This exponent can, I'm sorry, that comes up to be the exponent, so we get the natural log of 4 to the x minus 1 power. Now, that x minus 1, when it's in the exponent, you don't have to have the parentheses. You can if you want to. But if you were going the other way, if you were given what's in pink, and then you have to go and you make it look like this, you have to put those parentheses there. Otherwise, it's not going to be the same thing. Okay? We good on that? All right. So now this exponent gets to come out front. So we get x times log base 2 of 5. On 17, before we can do anything, we need to make it into an exponent. So this will become natural log of 2x plus 1 to what power? 1/3. Very good. Then that 1/3 gets to come out front. So we get 1/3 times the natural log of 2x plus 1. Okay. Any questions at all? All right. So same thing here. We don't have an exponent, but if I make this log base 6 of 64, what could my exponent be? -1. Good. So then when this comes out front, that's just negative log base 6 of 64. And just FYI, we could change 64 into 8 squared or 2 to the 4th, right? 2, 4, 8, 16. No, 2 to the 6th. And bring those out as well. There's just different things that you could do depending on what you need to do. Maybe more than one answer. Any questions at all? Okay, good deal. Then let me give you your assignment.